And that's the first 15 reasons that I can think of why I hate the University of Oregon and the Ducks. Okay, so anyway, here we are. We're going to graph this. Now, right off the bat, I think I had one little thing going. We're going to try to use 3-column tables with the understanding that if you don't need it, don't, because you'll see that these work well whether we do it or not. But I'm going to have an x value that we pick, and then we're going to have our scratch work in the middle, and then the y value that it spits out at the end. And I think you guys had this in your notes already, right? Okay, if you didn't have this in your notes, all I've done is I've made a 3-column table. When you guys did tables in algebra, I think you only did x and y, and then you had a bunch of scratch work on the side. Jade, all this middle column is for is just for scratch work if you need it. You can do it all here so that you can see exactly where it happened, so you don't have to try to track down where your mistake was randomly off on the side. Okay, the middle of every parabola, which is a weird thought. Parabola is just that shape that these guys make. It always joins at the vertex, which means in the middle of my table, what do you think we should put?
3, 1, 2.
So the vertex goes in the middle. Does that seem reasonable? Okay, so as we're looking at it, what is the x coordinate of my vertex? So I'm going to try to plug it in right in the middle. I'm going to pick roughly the middle. I'm going to say x coordinate of vertex. Now, if we're in this form already, this is my first step. And I don't want to confuse anybody with like numbers and stuff, so I'll just do it over here. This is step 1 of graphing these. That all the time. That's the first thing that I would do. Now, we should know that this should spit out a 1. That's what it should be, right? Let's verify that's true, though. When I plug this in, I'm going to check to see if we can do a little bit of mental math. This thing literally means that anywhere that there's an x, I'm going to replace it with a what?
3.
Okay, so here's the mental math check. Inside of my parentheses, the only place I have an x. What's 3 minus 3?
0.
I've got 0 here. It still gets squared, plus 1. The only mental math I'm expecting is that you guys can do 3 minus 3 right now.
I thought we were putting the. Oh, never mind.
Yep, and I just, like, we should get 1. I just want to verify that. So now, oh, go ahead.
Why aren't we putting 3 in the parentheses?
So I did. And yep, I'm glad you asked. Do you agree that if I plug in, and I want to switch colors so it's really clear, but I don't know if I'll be able to. What am I plugging in for this x? 3, and you're right. But then Lucy, and I think you can do this, and if not, that's okay. What's 3 minus 3?
0.
That's all I did.
Okay.
Okay. I think that you guys will be able to do that first part always in your head, but if not, that's okay. Okay, so even if we did 2, let's do this. This is 2 times 0 squared plus 1. What's order of operations tell us to do first?
Parentheses.
So I have a set of parentheses, but there's nothing happening inside, so I'll go to my next step. Okay, what's 0 squared?
0.
0. 0 times 0, 0. What's 2 times 0?
0.
Plus 1. Now, I just worked out and got 3, 1. This is my ordered pair. This is my vertex. Is that the same thing that agreed when we just took the shortcut? This first step here is a good check to make sure that we're good.
Why did we put the 2 there?
This one?
Yeah.
Because my function had a 2, I'm going to write the exact same function right here. Yep. So if it had been a 5, I would have put a 5 there. Okay. Here's where we might have a little bit of scratch work, and it's cool if we do, but I'm going to ask you a question first. Don't shout out the answer. 0 is the easiest number to square. Do you guys agree?
Yes.
What's the next easiest?
1.
Is there a value of x that I could pick that makes the inside of my parentheses a 1?
4.
So that was the shouted out part that we talked about. Jay thinks 4. If you can't come up with that number right in your head, quickly. There is scratch work that you can do, but it doesn't fit nicely in our table. What is the thing that's in parentheses? X minus 3. Now, if I want it to be a nice number, 0 squared is easy. That's what happens with the vertex. Is there a way that we could make just the stuff in the parentheses equal to a 1 instead, so that I'm doing with 1 squared? And this is the work that goes to the mental math that Jade used a second ago to get 4. Now, it might not look exactly the same in your head, but help me solve this for x. What x do I pick to make just x minus 3 equal to 1? How would we solve this equation?
Add 3.
4 minus. Oh.
And you're right. The logic is just the other direction, but you're good. Do you guys agree that it's when x equals 4?
Yeah.
If you can do it in your head, awesome. If you can't, awesome. Step 2, it doesn't really fit here, but in mine it says pick x values that make, and in this case I'm just going to refer to the parentheses like this. Whatever's inside of this, I'm going to say number equal to 0, which was the vertex, 1, and what's the next easiest number to square? 0 squared is easy, 1 squared is easy, 2 squared is easy. Okay, every time I'm going to do this. Some of you might use this scratch work, some of you might not. That's okay. You do you. I don't think we all need it every time necessarily, but if I plug in a 4, which is what we got when we try to make it 1, right? Let's plug it in and see if it shakes out the way that we're expecting it to. I'm going to write 4 for my next line. I'm going to do this so I can see it. When I plug in a 4 for this x, here's that little mental math. What is, when I plug in 4 right here, what's 4 minus 3? Okay, so I'm going to write 4, because I'm plugging it in, minus 3. That gets squared, and it's still plus 1. You do not have to have this line in your work if you're comfortable to skip it. If you don't want to skip it, that's okay. We'll do it here. 2 times 1 squared plus 1. That is all my scratch work, so that if I get the wrong number here, we're going to be able to find right away why did you get the wrong number. Like, where's the mistake? But help me out. What's 1 squared?
1,
Times 2?
2,
Plus 1.
3.
3. Awesome. We get the point 4, 3 is on our graph as well. Okay. One more. We could make the argument, and the argument I mean the parentheses here. Don't shout it out this time. Let's see if we can mental math it. Pick a value of x that makes whatever's inside these parentheses become a, we already did 0 and 1, it should be a 2. What should this x be to make x minus 3 equal to 2? Don't shout it. Think about it for a second. I'm going to give us like 15 seconds. I'll show the scratch work. If you don't need the scratch work, it's okay. I want the parentheses to become a 2. Okay, even if you can do it in your head, I still want an answer. What do I want the x minus 3 to be equal to when I plug it in?
5.
So I want x to be 5, and you guys just went ahead. I want it to be 2, and if you did it in your head or on scratch work, I assume you did something like this. X equals 5. Okay, when I pick a 5, I'm going to skip one line. Especially if I do the scratch work. We got 5 to make it a 2, right? Like I said, when is this thing equal to 2? And it was when x equals 5. We don't, if we do the scratch work, we don't really need this first step. I already know that it's going to be a 2 inside of my parentheses when I plug it in. Now you guys are going to help me one more time. 2 squared
4.
times 2. So 2 squared is 4 times 2 plus 1. So that's 8 plus 1, which is a 9. Okay, we have 3 points. Here's my second challenge. I'm going to let you guys do the rest of this problem. Here's what I want you to notice. And I don't have a good way to like summarize this. We'll try to get a step here. This is my vertex. My first point, I stepped how far away from it? 1. Could you step 1 the other direction?
Yeah.
And what would x be?
2.
I think it's 2.
Yeah. Oh, yeah. And that'd be negative.
So notice I went from 3, my next point is 1 away, right? So I'm just going to go 1 away this direction. I think it's 2. Does anybody not get what I just did?
Did you replace x with 2?
I'm going to put a 2 here. And Lucy, just to, and thank you, and I'm not trying to just call you out. Do you agree that when I went from 3 to 4, I just went plus 1? So what's the other direction? Instead of adding.
Minus.
And I'm just trying to make sure that I'm the same distance away on the x-axis. So I was 1 away in the positive, and I'm 1 away in the negative.
So. Okay.
And like, it might not click as to why yet, but we'll see it here in just a moment. Okay, my second point, to get from 4 to my next one, I went how far away? So to get from 3 to 5, it was plus 2. What about just from here to here? So what's the other direction? Minus 1 more, right? What does this x should be? 1. Okay, here's what I want you guys to do. Whether you need the, like, I've already chosen the x's, get me the function's values here. Meaning, you're going to do all the scratch work. Instead of x, you're going to write a 2. and then you're gonna see what number spits out at the end. Same thing with the 1. I'm gonna give you guys about a minute. If you are struggling, you're not sure what I'm asking you to do, please, please, please don't just sit there for a minute. That was way more obnoxious than a message. We just want to say. Alright, did you have your hand up before?
Did I have my hand up?
Yep. When I said, if anybody needs help, let me know. Were you just moving your hands? Or were you asking for help?
I think I was just moving my hands, but I didn't know.
Okay, so let's check.
So it would be 2. This is 2 minus 3.
Yep, and do you know what 2 minus 3 is?
Negative.
Good. So the first thing that I would write about is you gotta say 2 and then a negative 1 inside the parentheses.
Oh, because it's.
And then square, right? Plus 1. And don't forget, because we're just, only thing we're replacing is the x and we're negative. So check it out. What's negative 1 squared?
Negative 1.
What's negative 1 times negative 1? Or negative times 1. Good. So 1 times 2 plus 1.
You're 9.
And then you're gonna do the same thing with 1.
I've got a general question. The first thing we're trying to do is make it, right? And then there's other.
Is what?
There's more, right?
Well,
Yep.
my brain's working.
Okay, I was trying to.
So your table looks fundamentally different than mine.
Yeah, I know, I didn't know we were gonna make another one, so.
Okay. So I do want to highlight that very specifically. We went over this whole stuff. You're gonna be okay. Your table's gonna look wonky though. What's negative 2 times
The one?
What negative
Oh,
2 squared?
I have my space, so one.
Times 2?
Now,
Wait, no. Oh, I added 2.
Yep. You're good.
Okay, so we're gonna.
Lucy, was there a graphing sticking out on your desk when you sat back down?
Yeah, Mario has some.
Okay.
Um,
Yep. Will you give 1 to Jade? All right. Check it out. I saw your answers, but even if I didn't, I want to show you something. Because I paid attention to the distance, and I know that parabolas look the same on the left and the right, check out what I can do. This is the middle. This is a vertex, right? I have a sneaking suspicion that you guys got 3 right here. I have a sneaking suspicion that you got 9 right here. I didn't do any math just now. None. Not really. I didn't do any calculating. What I notice something is that it matches. This number and this number, as long as they're the same distance away from that vertex, they'll always match. Similarly, this number and this number will always match every time, as long as you pay attention to the distance that you go. Okay, everybody, you may not feel like super confident, but questions about making the table first. When you guys did this in Algebra 1, if you had picked 0 and 1 and negative 1 and so forth, we would not ever see the vertex, and it's not going to look like a parabola. Okay, so now we're going to graph it. And I don't think that the plotting the points is a huge issue. We've done our whole table. I could have made my eraser bigger. I don't know why I didn't. You guys seemingly are all getting your graph paper. As I look at this, do I need to go more up or down, like positive-wise or negative-wise? I don't even need any negatives, right? How about the x's? Positive x's or negative x's? So if they're all pretty much positive, you do not have to do this, but could I just focus on where everything is positive? If you hate that idea, I have literally no issue if you want to just do this every time, but you're going to waste a lot of space. In fact, I don't want to waste the space because I want to be able to write and see stuff, so I'm going to do mine and the positive stuff here. Okay. Picking a scale for your graph is something that a lot of people struggle with. Whatever a tick mark represents, the same distance, each tick better be the same amount of change. For this, I'm going to show you guys my easy way to cheat through them. What's the biggest y value that ever shows up? 9. Now, if I wanted to, I could jump by 3s. I could do 3, 6, and 9. What I will more commonly do is, because 9 is a weird number to put in my head, I would just come up to here and I'd say, okay, there's 10. You can jump by 3 if you want. You can jump by whatever you want as long as you put a scale. I'm going to pick something bigger that's a nice number, quote unquote, which means I don't have to eyeball it because I have graph paper. But if that's 10, what is this?
5.
5. Okay. Notice I didn't pick my scale until I saw the numbers that I needed. I'm always going to try my best to show the x and the y-axis, so maybe I'll have a little bit of extra. What about in the x direction? What's the biggest x value I need?
9. Sorry.
It's not 9, that was y.
5.
5. Now, maybe it's not a huge deal to make 6 each time. I'll do it since I have like only 5 numbers. That's okay. 1, 2, 3, 4, and 5. Okay. My scales are different on the x-axis and the y-axis. That's okay. As long as this distance along anywhere on the x-axis is 1, we're good. Okay. Let's start plotting some points, and I'm going to show you something real quick. I'm going to pretend like we only use these 3. I'm not even going to think about the other ones yet. Just those 3. Cool. So I want your guys' help. Somebody tell me how to graph this point, 3, 1. What do I do? Here I'm at the origin.
3 right, up 1.
So up 1. It's about here. I'm just eyeballing it. And then over how many?
3.
So I probably would have gone 3 over first and then up 1. But it's not perfect, but is that believably at 1 right here?
Yeah.
Close. Like, again, it's just a sketch. I'm not crazy worried about it. Okay, to get to 4, 3, I go to where it's 4, and then I go up to 3, right? Which is about there. And again, I'm just eyeballing it. If I were way off, I would have concerns. But unless I give you, like, here's a very nice piece of graph paper, be really careful. Close is good. Okay, one more. 5, and all the way up to 9, which is, I don't know, about here. Okay. Yesterday, I think I made the comment, but I don't have a prep, and I teach a lot of the same stuff throughout the day. Did we talk about some of you answered 3 points to graph a quadratic and some of you answered 5? Did that show up? When you graphed quadratics with whoever your Algebra 1 teacher was, and you made tables like this, did you use 5 points or 3 points?
I don't remember.
So that's fair. I'm going to take a reasonable guess and say used 5. Now somebody could answer 3 and be correct, because I want to notice something. Right now, if I just do these 3 with a nice smooth curve, does that look kind of like a part of a parabola? It shouldn't go straight up like that, though.
Yeah.
It should keep going out. That looks like a part of a parabola. Here's where we're going to be able to save tons of time. If I plotted the other points, I think that this point right here, when we check, and we should verify, but this point here, it's just going to land 1 away and be at the same value. And I'll try to make it the same value. When I plot my next one, it was 2, 3, right? Notice it's like I just moved it over. This point was originally 2 away from this axis of symmetry that we'll look at. So if I just go 2 more over from that, I just eyeballed those points just now. But I do want to check. I didn't look once at my table, but we should. Now that I've done this, I'm going to add one more little piece to make this super obvious. Does this look like it's a point 2, 3? Over 2 and up 3? That's like 2, 3 to me. I didn't look at the table, I just looked at this. Does this look like it's the point, I don't know, 1, 9?
Yeah.
I didn't use this though. I didn't look at the table at all. Here's the huge benefit of a quadratic. When you're looking at these, every quadratic ever is the same on the left and the right. They're always the same. If I were to draw a vertical line right through my x coordinate at my vertex, which can we all agree that this is my vertex right here? So check it out. We're going to draw a really faint vertical line right through it. If I draw the x line going through it, does it look like these points just reflected right over? Every time I'm going to use that to my advantage. When I actually make tables, I'm only going to do 3 points, starting with the vertex and then however far out, and then I will just simply reflect them. Okay, we don't really need 5 points. I mean, we do, but we only have to find 3 because we get the other for free. All right, when I connect these points, does it now look, whoop, let me make that more bold. I think that's a different color, isn't it? I can't tell for sure.
A little.
Does that look like a quadratic now?
Yes.
Does it look like a quadratic whose vertex is at the point 3, 1? All of a sudden, we can graph these super fast. I legitimately think that it's probably faster for you to do this than it would be for you to open your computer, type into Desmos, graph it, and then just blindly copy it. I don't care about your ability to copy graphs. Not what I'm after. I want you to graph them. Cool. Kian.
When you're making a table, how far do you have to go down third number? So like we started at 3, 1.
Yep.
How far did you
So I always pick 2 values on either side. So here I happen to be easy to jump by 1. So I just jump by 1 and then again by 1. We could have picked 50 if we wanted. And then I would just had to mirror it over. Let's do another one because I don't think that cleared up the question. But let's address the other parts of it. We will do another one and I'll see if we can make better sense of that. Okay. Was there a line that I drew that I reflected over? And what is this line? This is x equals, because it's always x. X equals what?
3.
X equals 3. Where else do you see written on the board, right next to that maybe, where I said the x value is 3? With different words. Check it out. The axis of symmetry always will be the x equals whatever the x coordinate of the vertex is. Every time. Every time. Okay. Does this function have a minimum or a maximum? A biggest value or a smallest value? So it's not yes or no, it's biggest or smallest. Smallest. Is there a fancier word for the smallest value? Not a maximum, but check it out. The minimum. What is the smallest y value we ever get? Minimum. There we go.
1.
Of 1 at which x value?
1, 9.
So careful.
Sorry.
Here's my smallest y value right here at 1. At what x value did that happen?
3.
Good. There it is. This one is going to be the easiest question that we've seen all day, I think. The domain of every purely quadratic, pure math. So no time, no negatives are of concern to me right now. What x values could I plug in? If I wanted to put 50 trillion on my table, could I?
Yeah.
I don't have much time to make that big number, but I could. Could I put in negative 50 trillion?
Yes.
No. If you want to.
I mean, yeah, I don't really want to, but I could. Which means, is there any number that we can't put in? We can put in all infinity of the numbers. What's an easy way to write that?
All real.
All real numbers. If you're graphing a quadratic and it's not a word problem, all real numbers, every time. Okay, go ahead.
If it's not a word project.
Yep. Because with word, and the only reason I say that is because if we have something that's happening with a word problem, it doesn't make sense to talk about negative time. Right? Like, I can't say I was at time negative 5 seconds, which maybe you can depending on the context, like 5 seconds before this. But typically we wouldn't do that. Just like if I had a tank that was filling or emptying with water, doesn't matter. Can I have negative 2 gallons in my tank? So maybe it wouldn't make sense to use negatives in that situation. But it just depends. Okay, what's the smallest y value that this function, and when I say the function, I mean the graph, the parabola that we just graphed, what's the smallest y value it ever gets to?
1.
Does it actually touch it?
No.
You say no, why?
Yeah,
Wait, this is y value, right?
Correct?
it does.
I think it does touch it. Because it's right here, right? It's literally the first point we put. How do I indicate that it touched it? Bracket or parenthesis?
Bracket.
We'll bracket. So we start at 1, and how high up does it go? Only up to 9 on my points, but these arrows tell me it keeps going, right? How high? Infinitely high. There it is. Okay. Let's do another one. Do you want another one together as a whole class, or do you want another one like, okay. I'm going to give us a slightly harder one. It's not going to really be any harder, but I want to highlight something. Okay. Before we move on, any questions about these? You always want 0 squared, 1 squared, and 2 squared when you do this. Okay, here we go. On B, and we'll do black here. I want to graph the following. Y is equal to negative, there's a negative 1, but I'm just going to write negative, x minus 0.5. Squared minus 1.
Y is the same as f of x, right?
Y is the exact same thing as f of x. Yep. All right. Very first thing, before I do anything else, I'm not going to write it, but can you guys tell me the vertex based on the h and the k location?
0.5 and -1.
Kian suggests 0.5, -1.
Yeah.
Okay. The second that you guys can tell me that, what's the first x value I'm going to put on my table? 0.5. Now, I'm not even going to plug in the y yet, Keaton, because I want to look at it. But this one, Any objections if I use three, like just 3 points, and then we do the reflection? Okay. So I'm going to make a table, X, and then I'll have all my scratch work in the middle. And whatever Y value it spits out. Okay, I'm only going to write down 3 points, and then we're just going to reflect it over the vertical line through the vertex. So there's a really important thing that I want us to notice and why I picked this problem. The first one I like is 0.5. What does that make the inside of these parentheses when I actually plug it in? So 0.5 is what I plug in. So in here I have 0.5 minus 0.5. And I'll write it. What do I replace my parentheses with this first number? 0. So because it does have an X in it, Kian, but we picked 0.5, right? So let's just see what this is. This is negative 0 squared minus 1. What's 0 squared?
I thought we replaced
0.
X with 0.5.
I did. And then the whole parentheses gets replaced by what then? Yep. Okay, Lucy says 0. What's negative 0 minus 1?
There's no positive.
It sounds silly, right? And it should, because negative or positive 0 is just 0. So I just did it so you could see the negative here. What's 0 minus 1 then?
Negative 1.
Was that what we were expecting for our vertex? Okay, here's the tricky part. On the last problem, when we did this, we jumped 1 away, right? And I can do that again, and I'm okay with it. Or we don't have to. Are you guys cool with doing 1.5, or would you like to pick a nicer number?
Nice.
So here's the weird part. If we pick a nicer number here, we get an uglier number here.
Then
Like, let's try 1 real quick, and I'm not going to write it down. But if I plug in a 1, I have 1 minus 0.5, which is 0.5 squared. What's 0.5 squared?
1.
That's 2 times 0.5.
0.5 times 0.5.
So, like, you see the issue?
0.25.
It is 0.25. Now, the alternative is if we just go 1 away here, I think it'll work out, though. Because in my head, I'm already thinking, all right, what value of X could possibly be chosen so that this is equal to 1? Because 1 is an easy number to square. It's up to you what you pick. I think we should do 1.5.
Yeah.
Okay, if I pick 1.5, I get negative. What's in the parentheses when I plug in 1.5? So in here I would have 1.5 instead, right? Minus what still inside of my parentheses? Squared minus 1. What does this get replaced with? Okay, so I'm going to actually do it underneath so I can do it larger. I'll just make sure I draw the distinction. That's just a 1 in there, right? Squared minus 1. And sorry to switch, but this was feeling like I was kind of jammed in there, so I'll leave space. Okay, help me out here with all of this algebra. What's 1 squared? Times a negative. Careful, it's negative 1. 1 times a negative is negative 1, minus 1.
Negative 2.
Good. We've got it. All right, I need 1 more point is all.
2. 2.5.
I could pick 2. I'm going to probably pick 2.5.
2.5.
And again, the math to do that is I'm asking myself, what do I do to make this a 2? And it's just add 0.5 to each side.
How many points would you need?
We're only going to do 3.
Why?
Because there's a paragraph.
Because then we'll get the reflection and we get 5 total. Yep, 5 total points plotted, but I think we only need 3 on the table. All right, so if I pick 2.5, what is inside my parentheses?
1.5 minus 0.5.
And that is
2.
2 and minus 1. Okay, what is 2 squared? Make it negative because they're negative. Negative 4 minus 1? Negative 5. Okay, here's my challenge for you. I don't want you to erase it, but there's a reason I picked this problem. It feels about the same, right? The numbers are a little uglier. Here's why I talked about that other one. Don't erase yours, okay? I'm going to erase this just so I could add something to it. If I had done 5 points, which we're really going to have 5 because we're going to plot the other ones without ever doing it, can anybody tell me the next number that I should write here if I wanted to show them all on my table? Negative 0.5 is what it should be. Now, it looks weird, but notice, add 1 to it, subtract 1 from it, it'd be negative 0.5. I'm not actually going to draw it, and I don't care about it because we're going to plot it, but it can be weird sometimes. Okay, to graph this, here we go. I'm looking at my x's. I need a little positive, and I know because I'll reflect it, I'll need some negative, but all my y values are negative. This is the only part of the graph that I care about. That's it. Am I going to put a tick at every 0.5, do you think? No. What do you suggest I jump by? If I make that a 1 and a 2 and a 3, can I pick out 0.5 and 1.5 relatively easy?
Yeah.
Yeah. And here's negative 1 and negative 2, just in case we wind up needing them. How far down do the y values that we have chosen go? Smallest y value on our table. Negative 1, it gets smaller than that. And it's a weird idea because you might be thinking about size. The most negative, negative 5, right? Okay, I have the ability to just count all 5. If this number was any bigger than 5, I'm going to be jumping by something. Whether it's 2 or 3 or 10, doesn't matter. I would never put more than 5 ticks unless I absolutely had to. Okay, I want you guys to plot these 3 points first for me. I'm going to come and be nosy and look at your pages. And then I'll come back up and we'll talk about how to get the other 2 points that I need for free. On this one, because it's so small, what I would suggest doing is I put a tick here. So every 2 I put a tick. Now I just write a 1 underneath. Or if you don't, I'm always going to assume it's a 1. So that 0.5 is right here. It's easy to find. That is weird. Close. This part, I don't love it. We'll talk about why. Is this 1? Negative 1?
Yeah.
So that's supposed to be negative 0.5. So let me catch up. Let me do the first 3, okay? Like, I don't think you're wrong, but the scale there is small, right? Okay. Did everybody get these points? 0.5, negative 1. It's about there.
Yeah.
That's my vertex. I won't draw another point this high. Okay, the next point is 1.5, which is about here and at negative 2.
Yep.
And the third point is at 2.5, and it's at negative 5. 1, 2, 3, 4, 5. Right here. These are my 3 points. Okay, for this one, I'm going to do the exact same. I'm going to draw through these 3. That was the best that I've ever drawn that line, just for the record. It'll never be that good again. And then you don't physically have to draw it, but I think it helps. I'm going to draw a vertical line passing right through my vertex. This is my axis of symmetry. It's the line that I'm about to reflect over to get my other points to make my parabola like really look like a parabola. I'm going to get these points for free. So here's my vertical line. And yell, I'm not 100% sure, but I think that you might have reflected over this line and then put another point right here. I think that when you did it, and I didn't look super closely, so I could be wrong, but I think that you acted like this was your line and then you put another point right here.
Yeah.
Okay, so that is not quite right. Drawing this vertical line will help. If I tried to reflect over this, it just lands on itself because there's nowhere, it's on the line already. It won't move. So let's go to the next point. Do you agree that for this point, I'm only 1 away? Or a box, like half a box and half a box, right? So check it out. I'm going to go half a box and half a box, and I'm going to get this. I'm just reflecting this over this line right here is all I'm doing. This one, I'm at this y value, whatever it is, it doesn't matter. I have it plotted. I go half a box, 1.5 boxes, 2 boxes away. So if you don't understand what I'm doing, here's my half a box, here's a full box, and a half a box. I'm 2 full squares away, right? So here I am. I'm just going to go 2 units away from here at the same y value. So here's 1 unit, here's 2. I think that's my next point. I didn't need to see it on the table to be able to graph it because every single parabola ever will just fold over itself. Once I have these 3 points, I will just try my best to make this a nice smooth curve. And here's my lovely parabola. Every single time. There's other values that would work. I'm only showing you the simplest ones, the easiest way that I know how to do it. Okay, with this, we're going to answer all those other questions that came with it really quickly. What is my vertex?
0.5 and
Vertex is at 0.5, or 1/2 if you'd rather, and -1. We knew that right from the get-go because we started with it. Okay, can you tell me the axis of symmetry, the vertical line that we drew? What was the x value? Always there.
0.5.
X is 0.5. And if you look at this pink line I've drawn, notice at every point along it, regardless of the y, the x is always 0.5. That's why it's this line. Okay, does this have a minimum or a maximum? Where is the maximum? So the maximum is at y equals -1. That's the value. When x is what? Notice, all three of these are just different versions of what's your vertex, essentially. Okay? Can you guys tell me the domain of this function? Okay, let me be more specific. Tell me the domain of this function. All real numbers. Probably not a great thing for me to say, but if you had no idea how to answer a domain question on a test or a quiz, shot in the dark, when I tell you to take that, because that's the language I use, I would just write all real numbers. Good chance it might work. Okay, hardest question. I want you guys to write down your range. Don't just shout it out. Write down your range, and we'll give you about 15 seconds. I want to see if we come up with the same range. All real numbers. So all that means is that any number that you ever pick, it doesn't break my function. And there's only a couple things that you know that break stuff, like we can't divide by 0. So if I had in this function, we never will have an opportunity to, so we don't have to worry about it. Okay, the range. We always go low to high, most negative to most positive. What's the most negative value this function ever gets?
Infinity.
Ooh, I love it. My table's at -5, but the graph, because it goes forever, it goes down to -infinity, and it keeps working up and up and up and up until what's the very highest y value? -1. And do we actually touch it? Yes. Boom. We're done. These graphs feel better or worse than you remember, or exactly the same as when you did in algebra years ago?
Better.
Better? Okay, here's my big question. It'll feel better now, right? Always a concern with math. It feels awesome. Everybody's doing well. You get home and immediately ugly cry because you realize that it feels good because I'm here helping you. Not that any of you would look ugly even if you were crying, just for the record. Okay, I'm going to let you help make this decision. Are we am I going to give you one more problem right now to work until the end of class, and then we'll have time in class tomorrow to work on some homework, and then do a little bit more lecture and word problem stuff? Or do you just want the homework now? Do you want homework tonight is a real question. Not what I was expecting, but I'm good with that. Okay, so for tonight, homework 2.1.1. All this means is it's first section of chapter 2, and it looks like we're going to have 2 days of stuff. You will find this assignment, I believe, on page 66. But if I'm wrong, remember, it's at the end of section 2.1. Okay, I'm going to add some problems to this tomorrow with the understanding that if you don't do any of it tonight, tomorrow night might suck, just in all honesty, because there'll be more problems tomorrow. We'll have a little time in class, but I want you to do problems 11, 12, 23, 24, I'm just going to call it 24 through 28. I don't know why my 2's were different there. But then you can skip number 25 and 27. So maybe that wasn't really worth the time. In hindsight. Okay. I anticipate if you come with good questions about these tomorrow, like that would be an awesome use of our time. I will not collect this assignment until Thursday because I will add more problems to it tomorrow. Cool. All right. We have 2 minutes. If you're going to start on stuff, you can, or we can real quickly try to learn the Greek alphabet.
Greek alphabet.
Anybody want to learn some Greek letters? Okay. Do you know any?